In this video, let's take a look at arithmetic sequences as functions. So at the top of our notes, the explicit formula for arithmetic sequences that we know is useful to find any term in a sequence is a sub n equals a sub 1 plus n minus 1 times the common difference d. The recursive formula is a sub n equals the previous term, which is a sub n minus 1 plus the common difference d. And the recursive formula we know is useful to find the next term if we know what the previous term is. So in our example, Scott has decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the bar graph as shown to the right, with day 1 showing he completed 3 push-ups. After 4 days, Scott feels confident he can continue this pattern of increasing the number of push-ups he completes each day. So let's make a table that represents Scott's function of his push-ups. So we have day 1, we can count that he completed 1, 2, 3 push-ups, and it was also told to us that on day 1 he completed 3. In day 2, he completed 1, 2, 3, 4, 5. In day 3, 1, 2, 3, 4, 5, 6, 7. So day 3, he completed 7. And then day 4, and what we can see already is each time we're adding 2 push-ups, or we should say Scott added 2 push-ups each day. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the pattern did continue to add 2 push-ups a day. So if we wanted to continue this table, we can continue to add days. So 5th day, Scott would have completed 11 push-ups. On the 6th day, if we add 2 more, Scott would have completed 13 push-ups. And on the 7th day, he would have completed 15 push-ups. So we could definitely fill out the rest of our table pretty easily. It says, what is the domain in Scott's situation? So the domain is the independent variable, or our x value, or our input is what we want to think about. So the domain in this case would be the number of days. And if we wanted to, we could list them as a set. So we know that Scott did his push-ups for 1, 2, 3, 4 days. And it says, what is the range for Scott's situation? So the range is the opposite of domain. It's the dependent variable, it's the output, and it is the y. And so the range would be his number of push-ups he did each day. And if we wanted to list those out, we could say that would be 3, 5, 7, 9. So as a sequence, we continued our table. But technically, we only know what Scott did for these 4 days. So that's all I'm listing for the domain and the range. So let's also add that the domain is the independent variable. It is the input value. And it's also like our x values is what we like to think about. And then the range is the dependent variable. It's the output values, or we also call it like our y values. All right, the next question asks, does Scott's situation represent a function? So we want to think, does every input have exactly one output? So we can look at our table and see that on day 1, he completed 3 push-ups. And on day 2, he completed 5, which is a different number than day 1. And it continues that each day he did complete a different number of push-ups. So we could say yes. And the reason is every day, which was our input values, has a unique number of push-ups, which is the output value. All right. Question 4 says, what kind of sequence is represented here? Explain. So if we look at our table, we saw that we had plus 2 push-ups each day. So if we add 2 push-ups each day, that is known as a common difference. So this is an arithmetic sequence for that reason, because each time you're adding 2. So let's write, because it has a common difference of positive 2. or adding 2. Okay. The next question asks us to create a graph of this situation. So let's grab another color and let's plot our data. So on day 1, Scott completed 3 push-ups. So for the X, this is number of days. And for the Y values, these are the number of push-ups. So we want to go over to 1 day and up to 3 push-ups. On day 2, he completed 5 push-ups. So we want to plot 2, 5. Day 3, he completed 7. So we plot 3, 7. And then day 4, he completed 9. So that would be the graph of his data. It says, write an explicit equation to represent this situation. So the explicit form, so remember we wrote those at the top, is the one that's useful to find any term in our sequence. So we would say that is a sub n equals the first term, and the first term would be 3 because he completed 3 push-ups on that first day. So let me write a sub 1 equals 3. We can also write the d was equal to 2 because that was our common difference. So a sub 1 equals 3 plus, and then we always put n minus 1 times the common difference, which was 2. All right, then it says write a recursive equation to represent this situation. So that's when we have the one where we know the previous term. So a sub n equals the previous term, a sub n minus 1 plus the common difference, which we know is, oh, not 3. I'm thinking of the first term. It is 2. Okay, so then it asks us to write Scott's situation as a function, and then it asks what is the independent variable and what is the dependent variable. So Scott's situation, to write it as a function, it would be best to use our explicit form because we can simplify that to look like a function with an independent and a dependent variable. So I'm going to write that again down here. A sub n equals 3 plus n minus 1 times 2. All right, so to make this a little cleaner, we can distribute the 2 to this n minus 1, and then we're going to combine like terms. So let's put a sub n is equal to 3 plus, and then we want to say 2 times n, it would be 2n, and 2 times negative 1 would be negative 2 or minus 2. And then continuing down to just clean that up a little bit, we can add together 3 and negative 2 to combine them because those are constant terms. They're just numbers, so we can add those together. So I'm going to put 2n first because that one has a variable. We like to write that one first. And then I'm going to put 3 plus negative 2, which would just be 1. All right, so we'll bring that over here. Now I've cleaned it up. I've got a sub n. So any term would be 2 times the number of the term I'm looking for plus 1. Now the independent variable is your input, which is your domain, and I wrote that in purple at the top, so I'm going to add that is where your independent variable would be, which is your input, which is also like your x. And then your dependent variable, which is your range, would be this one. So this is your output, which is dependent on your input. So dependent, it's your output, and it's like the y value. So what we can do is we can rewrite this form if we wanted to. It's in good function notation right now, but we could also say that is the same thing as y, because that's our output, is equal to 2x, because that's our input, plus 1. And those would really mean the same thing. All right, so that's enough for this part of our notes.